A4, a calculation question. So question A4 tells us that Elena reacted 0.765 grams of aluminum oxide with 100 cubic centimeters of 0.1500 moles per cubic decimeter of sulfuric acid and collected 1.368 grams of aluminum sulfate. A asks us to construct a chemical equation for the reaction, including state symbols. So aluminum oxide reacts with sulfuric acid to form aluminum sulfate and water. Let's balance this step by step. We start with aluminum oxide, which is Al2O3 plus sulfuric acid, which is H2SO4, reacting to form aluminum sulfate. Al2 open bracket, so open bracket SO4 close bracket 3 plus water, which is H2O. To balance it, we need 3 sulfuric acid molecules to provide the 3 sulfate groups, and that gives us 6 hydrogen atoms, which form 3 water molecules. So the balance equation is Al2O3 plus 3H2SO4 will give us Al2 open bracket SO4 close bracket 3 plus 3H2O. Adding state symbols, aluminum oxide is solid, sulfuric acid is aqueous, aluminum sulfate is aqueous, and water is liquid. Then moving on to question B. So question B asks us to determine the limiting reagent in this reaction. Determine the limiting reagent in this reaction. So here's how we approach this step by step. First, calculate the moles of aluminum oxide. The relative molecular mass of Al2O3 is 27 times 2 plus 16 times 3, which gives us 102. The moles equation, moles equals to mass divided by molar mass, so 0.765 divided by 102 gives us approximately 0.0075 moles of aluminum oxide. Next, we calculate the moles of sulfuric acid. Moles equals to concentration times volume in cubic decimeters. The volume is 100 cubic centimeters, which is 0.1 cubic decimeters. So moles equals to 0.1500 times 0.1, which gives us 0.015 moles of sulfuric acid. Now compare this to the equation ratio. From the balance equation, 1 mole of aluminum oxide reacts with 3 moles of sulfuric acid. So 0.0075 moles of aluminum oxide would require 0.0075 times 3, which is 0.225 moles of sulfuric acid. But we only have 0.015 moles of sulfuric acid available, which is less than what's needed. This tells us that sulfuric acid is the limiting reagent because it would run out first. Moving on to part C. Part C asks us to calculate the percentage yield of the product. So first we calculate the theoretical yield based on the limiting reagent, sulfuric acid. From the equation, 3 moles of sulfuric acid produces 1 mole of aluminum sulfate. So 0.015 moles of sulfuric acid would produce 0.05 divided by 3, which is 0.005 moles of aluminum sulfate. The molar mass of aluminum sulfate, which is Al2 open bracket SO4 close bracket 3, is 27 times 2 plus sulfur 32 plus oxygen 16 times 4, all multiplied by 3, giving a total molar mass of 342 grams per mole. The theoretical mass equals mass times molar mass, so 0.005 times 342 gives 1.71 grams as the theoretical yield. So the percentage yield is equals to actual yield divided by theoretical yield times 100. The actual yield given was 1.368 grams. So 1.368 divided by 1.71 times 100 gives us approximately 80%. That's question A4 complete. 8 marks in total. Now let's move on to question